Hey, everybody. I'm hoping this can be interactive. Okay. So, first talk, you are not asleep yet, right? When I ask a question, think about it and raise your hand or give me some kind of feedback. Okay. Um, what I wanted to cover today and talk about in general relates to vector search. So, maybe the first question to kick us off, who heard about vector search? Majority. Okay. Who tried to build some kind of vector search based system? Okay. And who has it running in production? Okay. So we went from about 60% to about 6 people. So let's say we can conclude that vector search is not a solved problem yet. And we have been working for a few years on actually figuring out what's wrong with it and how you can get it to production faster. Because if you are one of those people who is trying to do that, that's the kind of stuff that gets you promoted, right? And at the end of the day, that's what we are all trying to do at our job. Cool. Maybe to kind of motivate the topic, there is kind of like a pretty big divide right now. There is big tech using vector search for many years. Many of the experiences that you interact with every day are powered with vectors. And all of this stuff runs on custom trained models, right? So companies are training models to turn their data into vectors for recommendations purposes, search purposes, anything from matching users to ads, fraud detection. It's all custom models. Okay, so that's the kind of people who run this stuff in production. And then you have the rest of us, right? Who pick up a vector database, right? And they try to make it happen. If you have been looking into vector search, you might have noticed that there are quite a few vector databases out there. And so the first resource I wanted to share with you is a table that our community is managing that right now compares 44 different vector databases across about 40 different features. Okay, so if you thought that you know about 6 and it's like way too many, no, there is like way more. They differ on all kinds of different features. This is a part of our solution to help you figure out, okay, how should I even compare these things? And so, that's kind of the place where the vectors go. Once you have turned your data into vectors, these databases help you index this data and find similar vectors quickly. Okay. All right. So vector search is important. It's powering many experiences we interact with every day. In terms of once you have these vectors, putting them into a database, there is 44 different databases. So we are covered, let's say, on that front. What's the missing piece? And that's what we will talk about today. We are, just maybe quick word about who we are, right? Why do I care about vector search? I'm one of the 2 co-founders of Superlinked. We are a San Francisco-based company with somewhat of a distributed team, but I'm based out of SF. We raised $9.5 million seed round, announced it earlier this year. And we work with vector databases on making vector search work. Okay, so our first 2 partners on the database front are MongoDB and Redis. You guys might have heard about, at least that the databases exist. You might not know that they actually also do vector search, right? So it's, there are vector search startups, and then there are all basically your traditional database that you have been using for many years, probably now also added vector search, right? So no matter where you look, the feature is there. And then the last remaining piece is, okay, how do we make good vectors, right? Because that's the thing that makes a difference between the results coming out of vector search being relevant or not. Okay, so I have 3 problems for you in terms of what's broken about vector search, we think. The first problem relates to metadata, right? So you might have heard about, and listen to these three problems, because at the end we'll vote about which one is the most serious. And if I don't cover something you have encountered, then I'll let you shout out what your problem with vector search has been. Okay, so this is my first one, metadata, right? If you think about the query like that, popular pens, okay? You are e-commerce, you sell clothes on the internet, you have a search box in there, okay? And people come in and they type popular pens, okay? Which pants are trendy, what should I buy? How would you serve that query with vector search? Somebody who raised their hand that they tried vector search, how would you, let's say you have a database of products, right? You have product descriptions, maybe product name, right? You have some text information about the products, but this query wants popular pens. How will we build that system that does that?
User rating, based on user rating.
Okay, so you'll collect ratings, you'll maybe collect how many people buy which pens, right? So you'll have this number for each product. You will keep track of how popular the pens are, or each product, right? And so you have a number, and then you have for each product, and then you have a description of each product, right? And so what then? Where does the number go?
Well, I think you're optimizing. If you're looking at user rating primarily, you're optimizing for highest rating that's viable, meaning that there's like some depth there.
Mm-hmm. So how would you put this kind of data where you have the popularity signal and the description into the vector database? Like, what would the popularity be? And like, just a hint, it's like the word highlighted.
Some kind of nearest neighbor search that involves rating and pants.
Yeah, that's right. And if you look at the vector database, it allows you to do a nearest neighbor search in the space of the descriptions, right? Text search. But the popularity is kind of handled a little bit on the side, right? It's a number you can filter by, let's say. So
it's ambiguous, yes.
Yeah. You can, filter by popularity, but for that you need to somehow understand the query. You have to tease apart the fact that, okay, this user wants filter on this metadata, and then they want proximity on how much of a pens the object is, right? So the treatment of the query, it's like super not obvious, because the database gives you the ability to turn this whole string into a vector and then do a similarity match, right? But the word popular references metadata, which is disconnected from the description of the product, right? And you can like re-rank, you can filter, but it's it's sort of like not fully integrated, the metadata aspect of the data. Anybody has like sort of like, am I making some degree of sense? Yeah.
The way I use metadata was because my name was Rajkumar, and every time people search me on Yahoo, I came number one in San Francisco. So I was on top. So just people say Rajkumar, so I come up at Rajkumar in San Francisco. But later on, after 1 year, the Yahoo Mail, GeoCities became Yahoo Mail, and then it became, Google Mail. Then my name disappeared from the query. People said Rajkumar, they didn't find me on number one page. Right. So what I did was I tried to use metadata, where I try to define myself in different ways.
Okay, so search is hard. Okay, problem number one, metadata. I just realized I have to like speed way up. So let's keep going. The problem is that, let's say half of your database is pens. You can't get all the pens out of a vector database, or all the things kind of relevant to the term pens, and reorder them by popularity, because you'll be pulling half of your database out into your application server. So re-ranking kind of doesn't work, and filtering doesn't work, because what is popular? Is it 3 stars, 4 stars? That's hard. So think about it. How do you integrate metadata handling into your vector search? Problem number one. Problem number two, this kind of query. So let's say you are building RAG for helping support agents, and support agents often have some kind of manuals, and those manuals contain complicated information. And so let's say they would want to run a query like this: how to assemble the burner. And let's say that the document that has the information looks like that. Okay, somewhere in there is a burner. It has some parts. How can vector search help answer this question in this case? And to know what the problem is here, you also have to know that normally the way vector search is done over documents is in 2 steps. First, you OCR the document, you pull text out, and then you index the text. Unfortunately, this OCRs very poorly. And so, this is how it looks. It gives you a list of parts. And of course, the important information of how those parts relate to each other is lost, right? And so you will not be able to answer the question if you just read the documents as text. This is the problem number 2. Of course, it's not just manuals for HVAC systems, but it's also present in any other domain. Once the document gets a little bit complicated, if you try to pull the text out of it, you will fail. And the problem number 3 is the infrastructure around your vector database gets complex over time. You need to, you start with your data. You want to update the database in an ongoing way as the data changes, right? The popularity counter on your pens increases. You want to update it as fast as possible. But maybe you are loading historical data, so you want your batch pipelines as well. You want to process the data, create some Spark jobs, right? Eventually make vectors, put them into a database. You have a query server running on top of the vector database, and your application up there using the query server and feeding data, sort of clicks or thumbs up, down, back into your data warehouse. So when you build vector search systems, they get complex over time. And the problem with that picture is that you control kind of each of those steps separately. Usually you have data engineer writing the pipelines. You have, let's say you are building your own query server, and that basically desynchronizes from the pipelines. Basically, it gets complicated over time, right? So how do you control all of this? That's the third problem. So metadata handling, trying to pull text out of documents and failing, and complicated infrastructure, we think are the 3 main problems with making vector search-based applications work. From the people who had the hand that they ran something in production, any other problems that you encountered that you want to share with us? Okay, did I cover your problems, or you didn't have any problems? Okay, or we are shy. Maybe that's the last option. Okay, so I'll not, torture you any longer. There is a framework for this, right? That solves all these different problems. If you build something with Superlinked, I'll reshare your creation. Okay, I have 20,000 followers on various social media platforms. If you are looking for a job, if you are experimenting with AI, you build something with Superlinked, email me at daniel@superlinked.com, and I'll give you a shout out everywhere, and I'll help you get out there. So it all starts with pip install Superlinked, as it usually does when you build with Python. It's a open source, free to use library, and it solves the problems I described. You start with playing with this in a Python notebook, for example, or your local script. And for that, the library is enough. Kind of looks like this. It kind of looks like a ORM for a vector database. You define your data objects with this kind of schema annotation at the top. You define your index. You define how both the text and the rating, right, gets handled properly, gets vectorized. That's what I meant by metadata is being handled properly. And at the end, you can do your query, popular pens, and get results out of the database that are both popular and pens at the same time without re-ranking, without filtering. You just get popular pens. What if you want to run this as a service? You install our command line tool and write Superlinked run. And now you get, API endpoints on a local service that you control in the same way as the library. So it's reproducible. You can push data into it. You can run queries, and it manages the underlying vector database. Okay, so if you thought, okay, I don't want to kind of learn how to work with the vector database, now you don't have to, because Superlinked manages it for you. Index construction, all the configuration, putting data in, running queries. It's all done for you, and then you can switch to different databases and you can explore. Oh, this one is faster. This one is cheaper, right? You can figure out what fits your use case. Our first two partners are Redis and Mongo, but we are adding more. And then finally, okay, you work at a big company, you have millions of data points, you want to make a lot of vectors, and you don't want to run this on your local machine or on one computer in your cloud. Superlinked deploy, right? This orchestrates that complicated diagram I showed you before with the batch pipelines and streaming updates and all of that in your Google Cloud account. That's how we started. It runs in your Google Cloud. You have full control over it. You don't have to trust us with your data. Kind of looks like that. That's what you'll get when you do Superlinked deploy. As I said, handles everything for you. And that's it. So just a quick summary. That's our GitHub repo, right? So if you go to GitHub and search for Superlinked, or you go to superlinked.com and click on GitHub icon, that gets you to the repo. If you build something with Superlinked and share it with me, I'll make it worth your time. And we would love your feedback as people who are experimenting with vector search and trying to get it to work, right? Lots of people raise their hand that they have been playing with it, but so few hands actually use it, right? So our goal, we are 22 people, mostly ML engineers. I was ML tech lead at YouTube in YouTube ads for 6 years. So we are working really hard on making vector search work. And we would love your feedback on how we are doing and what the use cases are you are working on and how can we help you do it better. So that's my email. That's the GitHub repo. And that's it. Maybe just a quick summary. How can we do it without just pulling the text out of the documents? How do we get our vector search actually understand the picture? And the first signs of this actually working were the OpenAI clip model that can turn images into vectors, but is trained more on images of everyday things, right? So you can search for cat or a dog or a whatever table, right? And you could prompt the model by text, but it can also encode image into the same vector space. So this has been possible for more than a year now, or maybe 1.5 years. And of course, there are many open source fine tunes of that model. And there is fashion clip if you are in fashion e-commerce and you want to distinguish between t-shirts with long and short sleeves and so on. But that family of models doesn't really work on pictures like this, right? Pictures like this contain some amount of text and a complicated structure. And it's basically this summer that in sort of open source research, models became available that basically the way they work is you take a page, you treat it as an image, you slice it up into squares, about 1,000 squares, like a lattice. And then each little square of that page gets a vector. And those vectors encode basically what's on that page without taking the text out. And those models, just think about it as a model that has kind of the vision part. It can consume the image, and then it has the language model part. And so that's the part that also allows you to query it with text, right? And so it can project this kind of page into vector space, and it can also project a query that's textual into that same space. And through that, you can find out of a big set of documents, the 5 pages that are relevant to, let's say, burner stove assembly. And then you take those 5 pages and together with the question, you feed them to a vision capable, like GPT-4o, for example. So you give it the query, the 5 pages, and then without extracting the text, even at that stage, the model kind of looks at the 5 pages, the question, and produces an answer. So at no point in that whole pipeline, you are pulling text out from the page.